Physical Science, grade 11 and 12. I welcome you to today's lesson. We are going to look at redox reaction. In the previous lesson, you'll remember the focus was on determining the oxidation number. So the knowledge that we acquired from that lesson, it will be very useful in this second lesson. So what is this redox reaction? The word redox is the combination of two words, which is the reduction for RED there, reduction, and then OX is oxidation. A redox reaction is a reaction in which electrons are transferred. There must be a transfer of electrons. As you can see here, I've put something for you which one can use as a memory aid. Oil, RIG, for oil is oxidation is loss. Oil stands for oxidation is loss. Oxidation is loss. And then RIG there, reduction is gain. Reduction is gain. One can utilize this to remember which one talks about the loss and which one talks about the gain. So the reaction has two parts. The redox reaction has two parts, which is the oxidation half reaction and reduction half reaction. So oxidation half reaction involves the loss of electrons. It involves the loss of electrons. Whereas reduction half reaction involves the gain of electrons. So I want to talk about this gain of electrons and loss of electrons. But first, I will look at the reduction part, which is the gain of electrons. Let me read here. During reduction, we know that there will be a gain of electrons here. During reduction, the oxidation number of an atom decreases. Very important. During reduction, the oxidation number of an atom decreases. On the side here, I've just put the number line and two lines with arrowhead, one showing oxidation, another showing reduction. Remember, now I'm talking about reduction. Here is the reduction. This number line is representing the oxidation number. So we have heard that during reduction, the oxidation number decreases. This is reduction. If you follow this line, it's going downwards. And if you move from this point going down, there's a decrease in oxidation number. This is the number line which is representing oxidation number. We are moving, let's say, for example, from 3 to -4. There's a decrease in oxidation number. So that's what happens during reduction. What does the decrease in oxidation number tells us? It means that the reactant has been reduced. If you see that the oxidation number has decreased, it means that the reactant has been reduced. And then what does this tell us about the electrons? There's a gain in electrons. There's a gain in electrons. When oxidation number decreases, it tells us that there's a gain in electrons. The reactant that is reduced is the oxidizing agent. Now, let's look at the example. We are given this redox reaction, and we know that there will be a transfer of electrons. Remember, I am talking about what happens during reduction. So, my job now is to identify a reduction half reaction in this redox reaction. My job is to identify a reduction half reaction. How will I see that this is a reduction half reaction? We know that during reduction, oxidation number decreases. So I have to check the atoms where there's a decrease in oxidation number. Look here, I have a Fe2 plus as a reactant, and then as a product is Fe3 plus. Let's look at the number of charges here. Here is 2, and then here is 3. There's an increase here in oxidation number. It means that this is not reduction, because we heard that during reduction, the oxidation number of an atom decreases. So let's check on the chlorine atom. Here we have 0 on the part of the reactant, and then on the part of the product, we have -1. 0, then -1. There's a decrease in oxidation number. There's a decrease in oxidation number. It was 0. And let me use the number line here. It was 0 on the side of reactant, and then on the side of the product we have -1. There is a decrease in the oxidation number. This tells us that the chlorine Cl2, which gave us Cl minus, is the reduction half reaction. This is our reduction half reaction. You can see that there is a decrease in oxidation number. When there's a decrease in oxidation number, we know that there's a gain in electrons. Electrons were gained here. Electrons were gained. As you move to more negative, it means that the electrons are being gained. As you move to more positive, it means that the electrons are being lost. So this is our reduction half reaction. So what do we do next? You must make sure that the atoms are balanced. If you check on the side of reactant, we have Cl2, but on the other side we have Cl. It means that the atoms are not balanced. What one must do is to balance them. If you put 2 here, you will see that now the atoms are balanced. 2 on the side of the reactant, and then 2 on the side of the product. Another thing that one must do is to add electrons to balance the charges. Is to add electrons to balance the charges. So we already know that this is our reduction half reaction. So when you balance the charges, the electrons which are going to balance the charges must be added on the side of the reactant. The electrons that are going to balance the charges must be added on the side of the reactant. Is when we have reduction half reaction. If we do that, remember here we have -2. To balance this -2, we'll add 2 minus on this side. At the end, the electrons will be balanced. Here, we were talking about what happens during reduction. So, the next part that we're going to look at will focus on what happens during oxidation. During oxidation, the oxidation number of an atom increases. During oxidation, the oxidation number of an atom increases, which means that the reactant has been oxidized, meaning that electrons were lost. The reactant that is oxidized is the reducing agent. Electron that the reactant that has been oxidized is the reducing agent. We'll do what we've done under or when we're looking at the reduction part. Here we're given a redox reaction. Our job here is to identify the oxidation half reaction, and we will be helped by checking the oxidation number of the reactant and the product. Let's look at Fe when it was a reactant and when it is a product. Here we have 2 plus, and then on the side of the product we have 3 plus. What happened to the oxidation number? There's an increase. There's an increase here. It was 2, now is 3. So if we check this number line here, it was 2. On the side of the product is now 3. This is oxidation. There's an increase in oxidation number. But an increase in oxidation number tells us that electrons were lost. This tells us that electrons were lost because we moved from 2 to 3. We are moving to more negatives. If we are moving to more negatives, we are moving to more positives. If we are moving to more positive, it means that we are losing electrons. If we move to more negative, it means that we are gaining electrons. In this case, we are losing electrons because we are moving to more positive. So, Fe 2 plus, Fe 3 plus is our oxidation half reaction. You can see that there's an increase in oxidation number. What do we do next after identifying the atom that has been oxidized? We then balance the atoms. In this case, our atoms are balanced. The next step will be adding electrons to balance the charges. Remember, for the reduction half reaction, addition of electrons is done on the side of the reactant. For the oxidation half reaction, addition of electrons is done on the side of the product. In this case, it will be done on the side of the Fe3 plus. But let's check the charges. Let me use this one here. On the side of the reactant, we have 2 plus, and then on the side of the product, we have 3 plus. Not balanced. To balance them, we have to do something on the side of the product. We have to add electrons on the side of the product. In this case, we are going to add A minus, which is one charge here. If you check now, 3 plus 1 minus, we get 2 plus, which is balanced to the one which is on the side of the reactant. So this is our oxidation half reaction. So what is it that one must do if you come across a question like this one, which says balance the following redox reaction? Is the very same example that I used when talking about oxidation and reduction. Here we are asked to balance the redox reaction. It means that one must do everything that I've done when I was showing you how to identify the oxidation half reaction and also the reduction half reaction. This is just a repeat of what I was doing earlier, but let's try to balance this redox reaction. You can see that here I've come and put Fe2 plus, Fe3 plus. We already know that this is our oxidation half reaction. Cl2, Cl minus, and this is our reduction half reaction. The next step, we balance atoms. We balance atoms. If we balance the atoms, you can see that Fe2 plus, Fe3 plus atoms are balanced already. But for Cl2 and Cl minus, they are not balanced. We put 2 here. That's why I've written Cl2 on the side of the reactant and 2Cl minus on the side of the product. The next step, we add electrons to balance charges. We add electrons to balance charges. Like what I've said, on the one for the oxidation, the addition of electrons will be done on the side of the product. And then on the one for the reduction, the addition of electrons will be done on the side of the reactant, like what I've done here. This is just a repeat of what I've done above. After adding the electrons, now you must make sure that the electrons in the oxidation half reaction and in the reduction half reaction are balanced. Let's check here. Here we have 1, and then here we have 2. Now we have to balance these electrons. If you multiply by 2. You multiply everything here on this half fraction by 2. The electrons will be the same as the one in reduction half fraction. Look what I've done here. 2 multiplied by 1. 1 will not make changes to this half fraction, but these 2 will do. And as a result, the electrons will be balanced. If you check in the next one here, I've showed you what I've done. I've multiplied this, everything here by 2. That's why I got 2Fe 2 plus 2Fe 3 plus 2E minus. Here I'll multiply by 1. There will be no changes. At the end, the electrons are balanced. What do we do next? Combine two half reactions. What falls under the reactant side in both reactions must remain there. You combine them on the side of the reactants. And what is on the side of the products, you combine them on the side of the products. What do we mean by this? You write everything, whether it is in an oxidation or reduction half fraction, on the same side of the reactants if they belongs there, and do the same to what belongs to the side of the product. In this case, 2Fe 2 plus Cl2 and also 2E minus, they will be on the same side. Even on the side of the product, 2Fe3 plus 2E minus 2Cl minus, they will be on the same side. What do we do next? We check if we have like terms. 2 electrons this side and 2 electrons this side, sign are the same. If I take this to the other side, to this side, one will be positive and one will be negative, and then they will cancel. No other like terms here, no other like terms. Then my final answer will be 2Fe2 plus Cl2, which give us 2Fe3 plus 2Cl minus. So if we check our final answer here, everything is balanced. Let's check the charges on the side of the reactants. This 2 minus 2 plus, we get 4, plus 0. We have 4 charges on the side of the reactant. Let's check on the side of the product. This 2 times 3 plus is 6, positive 6. 2 times minus 1, negative 2. Then that 6 minus this 2 gives us 4. So the charges are balanced. 4 on the side of the reactant and 4 on the side of the product. Let's check the atoms. Let's check the atoms. Fe2 on the side of the reactant, and then on the side of the product also 2. Let's check the Cl, 2 on the side of reactant and 2 on the side of the product. So everything is balanced here.